Hello, welcome to Pibble Tutor. I'm going to be working on Chapter 14, Integral Calculus 1, from IB Analysis and Approaches HO. So, for this question, we're supposed to find the most general antiderivative of each function. And there's a lot of parts. So, starting with part A, I'll do this work in blue. So, part A, to find the general antiderivative, or the integral of x plus 2 and dx, respect to the variable x. So, you can split this up into integral of x dx plus the integral of the constant 2 dx. And then you can just use reverse power rule for the integral of x. We're using reverse power rule, so you add you add 1 to the power, which it's 1. So 1 plus 1 is 2. And then you put it over that power, so 2. And then for the integral of 2, since that's just a constant, it's just going to be 2x, which is also kind of related to power rule, but you can just remember that. And, of course, plus c, because there could be a constant. You can take the integral. Alright, so now for part B. The integral of f of t equals 3t squared minus 2t plus 1. So this is a quadratic, but it's important to note that it's respect to the variable t, not x. So that would mean when I do this, which I'm also going to split this up into separate components, it will be dt, not dx. And then minus, and that subtraction can be outside of the integral because it doesn't change anything. So dt, and then plus integral of 1 dt. So then it's the same thing as last time. We're using reverse power rule. So 3t squared, the integral of that, you would take the 3 out. You can take the 3 out, multiply it times, so t squared. So you do t, 2 plus 1, which is 3, and then over 3. And then minus 2t, which is similar. Take that 2 out, and then t, 1 plus 1, 2 over 2. And then the integral of 1, which is the same as last time. You just put the variable. So t, and then of course, don't forget plus c. So then to simplify this, the 3's cancel out, the 2's cancel out. So it's t cubed plus, or minus 2t squared plus t plus c. Alright? Now for part C, we have 1/3 minus 2/7 x cubed. So we can split it up like the previous ones. 1/3 dx minus minus the integral of 2/7 x cubed dx. So now, like before, the constant 1/3 just becomes 1/3 x. Now for minus, so you can take this 2/7 out of the integral, multiply it times, then we're using reverse power rule, so you add 3 plus 1 is 4 over 4. So then plus c, and then simplifying, it should be 1/3 x minus 1 or x fourths over 14 because which is 1/3, yeah, and then of course plus c. All right, moving on to part D. We have f of t equals t minus 1 times 2t plus 3. So I think the easiest thing to do would be to expand this, factoring it. We get 2t squared minus 2t plus 3t, and then minus 3, which simplifies to 2t squared plus t minus 3. And the integral of this would be the integral of t squared dt plus the integral t dt minus the integral of 3 dt, which would be the integral of 2t squared would be 2t, and then 2 plus 1 is 3 over 3, and then the integral of t would be t to the power of 1 plus 1, which is 2 over 2. This is just reverse power rule. And then the integral of 3 would be 3t minus 3t. So and then we have to have plus c. Alright, now for part E, g of u equals u to the power of 2/5 minus 4 times u to the third. So for this, we would just take the integral of u 2/5 du minus, and you can take the 4 constant out, minus 4 u 3 du. So then we have u, we add 1, so I have 7/5 over 7/5, or over, over 7/5, so we take the reciprocal of that, and then minus 4 times u3 plus 1 is 4 over 4 plus c. So it simplifies to 5/7 u to the power 7 over 5 minus u4, and then plus c. Alright, so now for part F, we have f of x equals 2 times the square root of x minus 3 over 2 times the square root of x. So now we'll just take the derivative, the integral of 2 times the square root of x dx minus the integral of 3 over 2 times the square root of x dx. So for the first integral, take the 2 out, and then we have x to the power of 1/2 plus 1, so 3/2, and put it over 3/2, so times 2/3. And now at the next integral, we can take the 3/2 out, and now we have x to the negative 1/2, because it's the reciprocal. You add 1, So it's now just 1/2, go over 1/2. So multiply times reciprocal, which is 2. And now to simplify everything, we have 4/3 times x to the 3/2, and then minus 3 times square root of x, and then of course plus c. Now for part G, we have h of theta equals 3 times sine of theta plus 4 times cosine of theta. So we have to take the integral of, and we'll take the 3 out, sine of theta plus, we'll take the 4 out, integral of cosine of theta. Oh, and d of theta, d of theta. And now we do, so the integral of 3 times sine of theta, well, I have to think the antiderivative of sine. So cosine, the derivative of cosine is negative sine, so the derivative of negative cosine would be positive sine. So that would mean we do 3 times negative cosine of theta, and then plus 4 times, and then the antiderivative of cosine, well, the derivative of sine is cosine, so that would do 4 times sine of theta. So to simplify this, it's just negative 3 cosine of theta plus 4 times sine of theta, and then plus c. For part H, we have f of t equals 3t squared minus 2 sine of t. So we have the integral of 3t squared dt minus the integral of 2 sine of t dt. So for the first integral, take out the constant 3, then over 2 to our t to the power of 2 plus 1, which is 3, over 3, minus the integral of, take out the constant 2, so the integral of sine, which is cosine, or negative cosine, so make that positive, cosine of t, or, sorry for the, there, cosine, 2 times cosine of t. So then that just simplifies to 2 cubed plus 2 times cosine of t plus c. Alright, so for part I, we have f of x equals the square root of x times 2x minus 5. So we can expand this to get 2 times x to the 3/2 minus 5 times x to the 1/2. So then to take the integral of this, you can take the constant 2 out. So 2 times the integral of 3/2 dx minus, take the 5 out, integral of x to the 1/2 dx, which would give us 2 times x, and then 3/2 plus 1 is 5/2, and then over 5/2, which is multiplying it by 2/5. And then we have minus 5 times x to the 1/2 plus 1, which is 3/2, over 3/2, which is times 2/3, and then of course plus c. So it simplifies to 4/5 x 5/2 minus 2x to the 3/2 over 3, and then of course plus c. Alright, for part J, we have g of theta equals 3 times cosine of theta minus 2 times secant squared of theta. So the integral of 3 times cosine, so we multiply it times 3 times the integral of cosine of theta times d theta, and then minus, take the 2 out, and then we have the integral of secant squared of theta d theta. So the integral of 3 times cosine would be, so the integral of cosine would be sine, so we have 3 times sine of theta, and then we have minus 2 times, now the integral of secant squared, which is the, should be, I think, tan of theta. And we can't forget plus c. Alright, so for k, we have h of t equals e to the power of 3t minus 1. So for this, you just have to think of, so if we have to do integral of 3t minus 1 dt, you have to think that this is, e to the power of x. The antiderivative of that would obviously just be e to the power of x, but because we have that 3t, the derivative of, e to the power of 3t would be e to the power of, or it would be 3 times e to the power of 3t because of chain rule. So we just have to counteract that by saying 1/3 times e to the power of 3 times t minus 1, because that way we can double check this by taking the derivative of this. So the derivative of this would be 1/3 times, and then e to the power of 3/2 should stay the same, or e to the power of 3t minus 1 stay the same, and then we have to use chain rule to multiply this times a 3, which would cancel these things out. So alright, so now for part L, we have f of t equals 2 over t. For the integral of this, we can take that 2 out, or take the constant 2 out, and then we just have 1 over t dt. So this would just be 2 times natural log of t plus c. Since the derivative of the natural log of t would be 1 over t. Moving on to part M, we have h of t equals t over 3t squared plus 5. So we'll have to use u substitution for this. We'll try using u equals 3t squared plus 5. So then du 6t dx. Therefore dx equals du over 6t. So then we plug it in, the integral of h of t dt equals t, or the integral of t over u. We swap out dt, this is supposed to be dt, swap out dt for du over 6t, which gives us the integral of 1/6. So 1/6 times the integral of 1 over u du, which equals 1/6 times natural log of u plus c, which is 1 over 6 times natural log of which we had u was 3t squared plus 5 plus c. All right, moving on to part n. H of theta equals e to the power of sine of theta times cosine of theta. Okay, so I think this is a u substitution problem. I'm going to set sine equal to u. We have du equals the derivative of sine, which is cosine of theta d theta. Therefore, we can do the integral of h of theta equals the integral of e to the power of u times cosine of theta times du over cosine of theta, which those cancel out. So then we have the integral of e to the power of u, which is just e to the power of u plus c, which equals e to the power of cosine. I think, wait, or sine actually. Sine theta plus c. Moving on to part O, we have f of x equals 3 plus 2x squared. So the integral of f of x, we'll have to use u substitution. U is the inside, plus 2x, du equals 2 dx. The integral of u squared du equals, or u squared du, and then we have 1 over 2 equals u cubed over 6 plus c, where u is 3 plus 2x plus c.